So this video is about finding missing angles in a right triangle using trig, trigonometry. Just as a reminder, when we're talking about right triangles, this side's always the hypotenuse across from the right angle. If I was looking at this angle right here, then that would be the opposite side because it's across the triangle. And this would be what we call the adjacent side because it's right next to the angle, touching the angle. And then when you compare these different sides, we give them names. So the opposite side over the hypotenuse side is called the sine of whatever the angle is. The adjacent over hypotenuse is called cosine, and the opposite over adjacent side is called tangent. The way we remember this often is so, ka, toa, which this means sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So that just helps you remember this information. So previously we've used this to find missing sides. For example, to find this side right here, I could set up the expression using 72 degrees. That is the opposite side, and this is the hypotenuse. So the one that has to do with O and H is so, sine. So I would say the sine of 72 degrees equals 8.2 over x. And then I could solve for that missing side. I'm going to go ahead and leave it there because that's in a previous video. If you want to check out the video on finding missing sides, you can. But what we're going to do today is a problem like this, where you actually have two sides of the triangle. And if you wanted, you could even do Pythagorean theorem to find the third. But what I'm trying to find is this angle here, x. So instead of finding a missing side, we're finding a missing angle. It's the same information, almost the same setup, just trying to find the angle. All right, so if I'm trying to find this angle, that is the opposite side, and this right here is the hypotenuse. Once again, the one that has to do with O and H is sine, because so, ka, toa. So sine. So I know that the sine of angle x here equals 2.5 over 5. Remember, sine doesn't exist by itself. It has to latch on to the angle. So it wouldn't make sense to say sine equals 2.5 over 5 because the sine of what? So don't do that. It has to be the sine of angle x. This simplifies. If you want to simplify it to 1/2, you can. I'm just going to leave it for now. So the problem is I'm trying to solve for x, and I need to undo sine. And it's really tempting to be like, oh, well, I'll just divide by sine because it looks like they're being multiplied, but they're not. This is almost like you have the square root of x, and to get rid of square root, you have to do the inverse of square rooting, which is square it. The inverse of sine is literally called the inverse of sine or arc sine. Sometimes it's called arc sine. I'll show you that in a second, but basically it looks like this. Sine with a little -1, or sometimes we write out arc sine. Both of these just mean the inverse of sine. They undo sine. So if I want to undo sine, I'll just do sine inverse. If I do it to that side, I also have to do sine inverse to this side. So I'm going to do sine inverse, sorry, I'm running out of room, of this side. And sine inverse and sine cancel each other out, leaving just x. So really, all I have to do is type this into my calculator. Sine inverse of 2.5 over 5, or 1 over 2. So a few calculator options here. If you're using a TI-84, you'll see this right above, I don't know if you guys can see this. Right above, oh, it's so dark. So sine, cosine, and tangent, right above it, it has sine inverse. So you would do second sine inverse of 2.5 over 5. And there it is. 30 degrees is your answer. Do make sure you're in degree mode. So you need to check up here mode, and right here degree should be highlighted, not radian. So make sure you're in degree mode. If you're using a phone, the phone calculator has sine, cosine, and tangent, but it does not have the inverses. So if you don't have a TI-84, you can type this into Google, or I'll try to post some sort of trig calculator on Google Classroom so you can use that instead. If you want to just type it into Google though, it will work. You have to use the word arcsine. So in Google, just type arc, like literally in the search bar, just type arcsine of 2.5 over 5, and you may want to I think you have to say in degrees. So just type this into Google and it will do it for you. Okay, so that told me the answer was 30 degrees, which makes sense. This looks about 30 degrees. Let's try another one. But before we do, here are all the trig functions and their inverses. So to undo sine, you use inverse sine, or arcsine. To undo cosine, you do the inverse cosine. To undo tangent, you do the inverse tangent. And they literally just undo each other. So like if you have sine and inverse sine, they just cancel out and leave 43. Or if you have inverse sine and then sine, again, they just cancel out and leave x. Okay, let's look at a plane here. This plane is currently at 300 feet, or I don't know what the units are. It's traveled 400. I want to find the angle at which it took off. So I can set up a trig function here. This is the opposite side, and this is the adjacent side. The trig function that has to do with OA would be TOA, tangent. So the tangent of x equals opposite over adjacent, 300 over 400. You can simplify that. Again, you don't have to, but you could cancel the zeros there and make that 3/4 if you wanted to. And now, again, just to get x by itself, you got to do the inverse. So to undo tangent, we'll just do inverse tangent. Got to do it to both sides, got to keep it balanced. So just do inverse tangent of both sides and you get x by itself. So type this into your calculator, tan inverse 3 over 4 or 300 over 400. In Google, you could just type arctan of 3 divided by 4 in degrees. Remember, the phone calculator doesn't do it. Let me do it with my TI-84 real quick. So second tan inverse, 3/4. And it tells me that that is 36.87, that's rounded. There we go. All right, I want to find this missing angle right here. So should I use sine, cosine, or tangent on this one? On this one, it actually doesn't matter. If I want to use sine, I could say the sine, I'm going to call this x. The sine of angle x is opposite over hypotenuse. I could say the cosine of angle x is the adjacent side over the hypotenuse. And the tangent of angle x is opposite over adjacent, so 39 over 52. Any of these will work. Just pick your favorite and go with it. In fact, maybe even try a couple and see if you get the same thing. To get x by itself, on this one I'll need to do the inverse sine of both sides. On this one I'll need to do the inverse cosine of both sides. Sorry, I'm running out of room. On this one, you would need to do the inverse tangent. And you should get the same answer either way. All three of these should give you the same answer. Let's go ahead and see. So the inverse sine of 39 over 65. This one gave me 36.87. I think that was the same as the last one. See if this does the same thing. Inverse cosine of 52 over 65. Yep, same thing. And this one should also give you the same thing. So in that case, just pick your favorite and go with it. It really doesn't matter. All right. On this one, there's no triangle, so it seems like it might be complicated, but it's actually very straightforward. This is sine of c. If you want to get c by itself, you just got to get rid of sine by using inverse sine. Make sure you do it to both sides. You got to keep it balanced. And so that's it. Just type sine inverse in your calculator to get c. Or remember, you can also type it into Google. So you would type arc sine of 0.6561, and then you would have to say, I want this in degrees. Type that into Google and it should give you 0.6561, 41, about 41, we'll round it, 41 degrees. And you can check your work, right? Do the sine of 41 degrees, see if it gives you about this. Okay.